Well, welcome to the second seminar for MRC. This is on SolidWorks. I've had some issues with my laptop, so I'm going to be using the VMware SolidWorks here, so it's going to be a bit slower. Therefore, we're going to cut this down a little bit short and not spend too much time on things. But what I'm covering here is how to pass the SolidWorks Certified Associate exam. There's a number of exams. There's professional and expert, but you have to take the associate and then the professional and the expert before you can take any of the others. If you have an interest in these, I highly recommend doing them. There's also SolidWorks World, which is like their conference every year. I think it's in California most of the time, but you can get certified there also, and there's lots of classes you can take. So it's in Dallas this year. And then here for the SolidWorks Certified exam, you can, as a student here at FAU, you can take this exam for free. I'm not sure if it's the academic version or the regular one. I think the academic one is administered on campus, maybe for high school students. I'm not exactly sure. But there's a company called Solid Edge in Fort Lauderdale that is the distributor of SolidWorks for South Florida in this area. So if anyone's interested in getting certified, you know, with the higher level classes, you should talk to them. So there's a bunch of example questions online you can find. These are directly from SolidWorks on the exam. Some of them are older, some of them are newer. And it's basically the same thing as the easier ones. They're just more complicated parts and going to take longer to do things. So I'm going to start out with something simple like this. It's just a basic, I don't even know what this is. It looks like a cam for like a linear bearing maybe. The big thing to notice with this is first they give you these dimensions. A equals 50, B equals 70. And there's a huge part to this to make sure you pass the test. So the first thing I would do is go into Tools, and there's this thing called Equations. This is very important in SolidWorks. You can set up global variables. Any sketch that you make has a value. It'll save in here. You have to change the view, but it'll list under dimensions here. So you can make variables as equations. So now if you wanted like a over 10, you could set this variable equal to a divided by 10, and that's equal to 1. So anytime I change 10 to 20, this will update as well. So it's a useful thing in SolidWorks. So first thing I'm going to do is set b equal to whatever it was. What was it? 70 and 50. So that's the number one thing you want to do first when you start the exam is take anything that they give you like that and put it in your equations. Also, I like to check this box here that says automatically rebuild. Every time you change this, it'll rebuild the model. Otherwise, you have to go up and press this little button. Second most important thing to do is make sure you have the right units. And I think mine's incorrect. So to change your units, you can just go down to the bottom here and change it to millimeters or whatever you want. And you want to do that before you make any sketches or dimensions.
Hey, cool.
What?
Where is the formula speaking?
The formula?
Yeah.
Tools may go down to equations.
So you have to like I don't know if you noticed, but you have to hover over this little arrow for your tools menu to show up. Then you scroll down to equations, click that, and you can put math in here also. Like you can do like sine also. There's all kinds of things you can do in here.
How do you bring in more rows?
Oh, so once you put one in and press enter, another one will show up. So here you just click there and you can make C equal to 50, and as soon as you press enter, a new add global variable thing will show up. Another thing with SolidWorks is you want to be strategic with your models. You have to have a good idea of what you're going to draw before you just go and draw it. Often I see people start with like, this face, or, somewhere that wasn't methodically thought out from the beginning. What I would do is start on this face and extrude this whole piece outward like this. So that's what we're going to do. So the dimensions of this is A and B. Here it doesn't matter which plane you do. Also, I like to use the center point like this. It's just a personal preference. So if you click the rectangle box, you can get that option to get the center thing. So now this dimension is A, so I can say equal to A, and there's A. You get this little equation looking thing, sum, and then this is B. So now if I go up here and I change A to 20, that'll change automatically. So this is 67 millimeters total. So I'm going to extrude this. Again, I like to do mid-plane so it evenly spreads the whole thing across it. So this is 67 millimeters. Now the reason I can also set this equal to A, or I could say A times 2. See how you get the little equation thing? But they didn't give me a dimension as a variable here, so I'm just going to say 67. Okay, so what's the diameter of this circle? 38? Right?
Yeah.
Okay. And then it's 27 and 27 millimeters from one corner. It almost looks like it's in the center, but it's not. Whoops. So a nice quick key is Control 8. When you start a sketch and you do Control 8, it'll automatically go normal 2. A lot of professors will teach you to right click and do this, but in my opinion it's a little slow. Oops. Alright, so circle. 27 millimeters. It's 38, right? Yep. So now we can just extrude cut that through the whole thing. So now we have a break through this whole thing that's 19 in total. What?
So on your model, it looks like on the inside of that cut, it's already, is the whole thing already, like how it's all shiny and beautiful?
Yeah.
How do you get that to happen?
So that's just by default this little real view graphics, I think.
Okay.
I don't really like it personally. It just takes up more GPU power to render it.
Yeah.
Basically on the virtual machine.
Yeah. So I mean, once we finish it, we can go and render it, make it look really nice. But for now, it's not that useful in my opinion. Yeah. So now I'm going to cut out this piece here. Yeah, it's directly in the center of this piece, so we can just draw a rectangle. Actually, I want a different rectangle. This is 19 millimeters. Does everyone understand the concept of the fully defined sketch? Yeah?
You want to go over it?
Okay. So a fully defined sketch means that it's all black, basically. You can also see down here it says fully defined. And what they mean by that is everything in the sketch is stuck to something in relation to. So SolidWorks is a parametric program, meaning it has parameters for everything. So what I can do is relate this point to this line in these different ways. So I can say I want this to be at the midpoint of this line, or I can just say coincident. And Pierce is a little different. That's more like 3D view, but it would do the same thing as coincident here. So basically you just want your whole sketch to be black like this and say fully defined at the end. And you want to make sure you relate it to things that are important in the sketch later, because if you move or if you change the size of the circle later, you want this thing to change with it. This is the point of that. So what I did is I made these, this is a square, so by making these coincident with the circle here, it centers it on this circle as it should. So if I move this circle up or down or left or right, this extrusion will come with it. So I'll extrude cut that and through all. Alright, what's next? So let's cut this piece here.
Do you think you want to put that extrude cut on the correct side of the part?
Is that not on the right side of the part?
It's not. No. It should be on the thin side, because that's the side that was dimensioned to 27, and it's on the opposite side of that.
Oops. Let's check that. Oh yeah. Okay, so check this out. So Harold brought up a good point. But since this is parametric, I don't have to delete everything.
You just change the relations.
Yep. So now instead this is 27. Whoops. Exit the sketch and everything will go with it. So you can see here this rectangle is still coincident with the circle. Alright, so now we're going to do this piece, which is 3.3 by 29. I think it was 12.5 away. Yep. And then you can see here it goes all the way through the model. That's what that they call that a hidden line. So you can't really see it from this view, but you can see that there's something behind there. So also when you're in a sketch and you're done with your sketch here, it's all fully defined. You don't actually have to exit the sketch. You can just say you're going to do an extrusion or something. You can just go over to the Features tab, press Extrude Cut, and it knows what you want to extrude cut now because you were currently in the sketch. And we want to go through all again. Also, you have these options, right, for extrusion. You can go through all. Through all both means it goes in both directions, not just one. You can go to next, which is the same thing that we're doing here. It will just go until it comes to something new. We have to surface, which would allow you to extrude up to a certain surface, right? And if you had like a 3D surface, you could have it curve around that surface. Up to body, same thing as surface, but a body. But we're just going to do through all. So next I think I want to do this hole here. And this is 6.3 in diameter. So we make a sketch on the top. I like to just draw it somewhere, nowhere really specific, just kind of out of the way, and use my dimensions to define it to a certain point. Now that looks like it's in the center as well. In any other case, I might say that that was the center, but since this is the SolidWorks exam, I would just use the dimensions that they give you and not try to recreate and do it a better way. So now that's fully defined, we can extrude cut that. And here we can use our up to surface.
You can also use up to next.
Yeah, I think I like that better actually.
It should just go to the next surface.
So now we're almost done. We just have these internal like gasket looking things, and then this
Retention ring slots.
these slots on the outside. So let's do the slots on the outside first. So I'm going to make a sketch on the outside. Just going to draw a bunch of stuff here that generally looks like what I'm going for. Alright, now we know these here are parallel. So we can select those two and set a parallel relation. We'll do that for all of them. Whoops, not equal. And then these here are collinear. If you guys have any questions, just let me know. So it's 9.6 apart. Sometimes you get something funky like that where it goes out, but you can just drag it and pull it back in if your relations are good. Oh, you know what the problem is? It's that the angles aren't correct. Oops. There.
Looks like you have something defined as a perpendicular.
No, I don't. Oh, here, maybe it's this. Oops.
Oh, I see. They just sold perpendicular. Sort of perpendicular.
Where? The bottom?
Yeah.
Oh, this one. Okay. There we go.
There we go.
You know what? I got a better idea.
Why just make an X and then offset it?
Yeah, that's what I was thinking.
Would you just do that for construction?
Okay, so any of these lines, you can just go for construction, and now it's a construction line. So when you extrude it or whatever, or you do any features with it, it'll ignore it. It's not a, it's just for construction. But you can apply relations and stuff to it at the same time. Can I do, yeah, okay, bidirectional. So I did an offset here of 4.8, which I think is right. Yeah, 4.8. And then I set bidirectional, so it's going in both directions. What I'll do is I'll go convert entities, and that'll take all the lines on that face and make it a line on your sketch. So now I can use that to trim these away if I get the trim tool. So there's a bunch of different ways of using the trim tool. You have power trim, which is what I usually use. The rest of them, I doubt you'll find a reason to use them, but they could be faster in some situations. So with trim, you just hover over it and you just go like that. You just draw a line over it. And SolidWorks will do its best to figure out how to redo the relations. Sometimes you have to re-relate things, but here I don't think I have to. There we go. So now we're going to extrude this 1.5 millimeters in. That's that shape. Okay, and then finally, we're going to draw this little cut in here. Yeah. So I think what I'm going to do is, I can't tell how deep it is. Anyone see how deep it is?
There are 42 between each other.
No, I mean like depth cut.
It says all 20 right there, raised 20.
Oh, okay, yeah, this, okay.
Yeah, then
So let me see, maybe I'm going to make an axis along here. And then I'm going to make a plane.
you already did that. How do you do that?
Do the axis? Yeah, so under reference geometry, you have a bunch of things. I usually use plane and axis, but if you go to axes, you can make an axis along a bunch of different things. So say you wanted an axis across here, you would select these 2 points, and it would make a line like that. But since we selected this surface here, it knew where it wanted it. It was like a radius or diameter. I don't know how it does it, but see, it selected cylindrical conical face. And now we can use this axis to make a plane. So you select the plane in here. We don't have to do much else, but I'm going to define it. Oops. Yeah, see, I want it parallel to this face. So I selected the axes, and I wanted it coincident with that axis, so it's touching the axes. And then I want it to be parallel with the front plane. So now I have a plane intersecting that circle. Now I can use this to make a sketch on, but first I'm going to do a section view. not on the front plane, but on this plane. That way I can see what I'm doing. I'm going to make a sketch on it. I'm going to draw a little rectangle here. And it is 1.5 millimeters. And from this center axis, it was 20 millimeters, which was the depth, right? Yeah. And then it is I'm going to make another one. And here what I can do is I can set these equal. Whoops. Instead of redimensioning this one, I've already dimensioned this and it's the same dimension, so just set it equal. And I want these to be horizontal. And I'll make this coincident as well. Actually, I'm going to make it coincident with this edge. If you have a relation you don't want, you can just select it. That's what these little green boxes are. And just press delete on your keyboard. And then the dimension between these two is 42 millimeters. I think so, yeah. Yeah, it is.
Yeah, let's take us point to it and then.
And then it's 12.5 from that same edge to the outside edge. It looks to me like it's in the center.
Yeah.
But if you're taking a test, I would just use the dimensions they give you. And I think if we measured no, it's not. I don't think it'll affect the answer, but you don't want to get it wrong. Okay, now that we have that, we can exit this sketch. We'll go into features and we'll do a revolve cut. And the axis of revolution is this axis we just made. You can press OK, and it just cut that all the way through. We'll turn off the section view, and that's it. So we could also put some materials on here for some colors. I kind of hate the gray that they always do. Maybe a blue would be good. One thing we have to do though is here they told us that it is AISI 1020 is the material. So to set the material of your object, you just right click on it in the hierarchy. The top tree piece here. Right click and you go material, edit material. And it's this here. So we'll go apply. It actually changed the color on me. I'm going to hide this plane. I don't need it anymore. And that's the whole thing. So now what they're going to ask you is, what is the overall mass of the part in grams? So let's find out what that is. If we go to mass properties, it says 1127. There we go. So the answer is D. So what they would do is have you do this whole thing, and then the next question is going to say, what's the mass when A equals 100 and B equals something else? So let's go into equations and change this to 60 and this to 80. So now everything updated with it. And we can go back into mass properties and find what the new mass is. So it makes question 2 a lot easier. All you have to do is change those 1 dimensions and find the mass. If you didn't do that, you would have had to go back into your sketch and find where you made those dimensions and reset them and hope that everything else was related correctly. You guys have any questions? No?
Can we do an O?
Yeah, we can do something else.
How do you do a flow simulation?
We can do a flow simulation.
No, create an extension.
Will you show how to render it too?
Oh yeah.
Beautiful.
Okay.
Can you hide the axis?
We'll be here for a while.
Yeah, let me hide the axis.
Now it looks perfect.
So the render, thank you. So the rendering tools aren't enabled by default here. So we have to go into the add-ins, tools, scroll down to the bottom, add-ins, and here we want to set Photo 360 to active. If you, since I'm on the server here or on the VMware, if I set startup, it won't save by default. But if this was on your computer and you wanted PhotoView 360 to come up every time you open SolidWorks, you would check that box. So now we can add a background. So here, let's do this urban thing. And do a preview window. Always takes forever.
What was the last? Was it preview window? What was it?
Oh, it's on, you might not have the tab. Right click on one of the, do you have the render tab?
Yeah.
You don't have preview window there?
Oh.
Yeah, there you go. This is gonna take forever on the virtual machine.
Just end it there.
Yeah,
Cool.
but
So, can we do another one? 'Cause I wasn't able to do the entire one. I think I'm sorry.
yeah, sure. Oh, here it goes.
Oh. Oh.
Is it rendering?
Yep.
Yeah, give it time. It goes like 3 different renders. So it's fun.
Why are you here?
I didn't know how to do the equation. Stuff like
You want to try this one?
Yeah.
yeah.
Okay.
Yeah, what's the website so we can actually open this up as well?
Oh, this practice thing?
Yeah.
So if you just Google, like SolidWorks Certified Associate Practice Exam. It's like these 3 PDFs. But I can email this to you if you want or something. There's also a bunch of stuff on GrabCAD from people who have done this before, taken the test. All kinds of tutorials in here. So this is my SolidWorks, my GrabCAD page. We got a little Lego spaceship, yeah. Yeah. And this was AutoCAD actually. This wasn't even SolidWorks.
Ew. Gross.
Yeah.
How was it? Did you like mirror the little dots on it, or how did you have to individually experience each one? How do you do it?
So the only dots that you can see here are the ones that I drew. The ones that were like packed on top of each other, I didn't actually drew. I just kind of like stacked a bunch of blocks on top of each other, because you couldn't see them anyways. There's no point. But like all these back pieces, I had to like, you know, use a ruler to figure out the length of them and draw everything. And then in AutoCAD, it's not easy to place things like SolidWorks, where you can like mate things together. You have to like grab 3 points, and then you have to relate them to 3 other points.
It's not him, guys.
Yeah. It's outdated these days. So here's a more modern thing I did. This is a subwoofer that's actually in my car. And I tried to model it as accurately as possible. And I actually did a full HD rendering.
Yeah, how long did that take?
It took my computer like 10 hours. I think I went to work, started it before I went to work, and by the time I got back, it wasn't done. It was still working on it.
For that 10 seconds that there took like 10 hours.
Yeah. It's just 10 seconds long, too.
That's pretty awesome.
Yeah.
You got it so smooth on the other end.
Yeah. Well, that's the material you see.
Oh, okay. Figure that out.
What, the rendering?
You got the material because it doesn't show like plastic.
Yeah, so I didn't use SolidWorks to render that, actually.
Oh, yeah.
I used a program called KeyShot, which is way better in my opinion. And it's way easier to use, too. It's a lot simpler. And there's a little add-in for SolidWorks where you just press a button and it'll automatically open it in KeyShot. But yeah, all of these images are computer generated. That's not real. And then I also drew my television 1 week at home. This took a while. This is Inventor, SolidWorks Inventor. I highly recommend anyone who's like looking to get a job in like mechanical stuff to have a GrabCAD and put stuff up there. If you put a link on your resume and they click on it and they see stuff like this, it's really beneficial. And then they got this whole badge thing also. So I got this active uploader badge, but there's many other badges. Like if you win a challenge, they have challenges on here too. Yeah.
Go to the next part, bro.
The what?
Next
The next model? Okay.
I have a question about, I guess, importing and exporting objects and stuff.
Right.
What is compatible with SolidWorks? My workflow is with Blender. I guess it's not really.
Yeah,
examples.
if it's Blender, you'd probably just use STL, I think. There may be a better way to do it, because Blender is all vertices, right? Like SolidWorks is parametric, and everything's like defined via equations and like circles and stuff like that. So there's no way to really take the data from Blender, as far as I know, and bring it into SolidWorks. You know, you could still bring the model in and view it, Like I have a bunch of models actually like that are just interesting models, but they have no features related to them. They're just geometry. So you could do that, but if you really want to have like the features available to edit, you have to redraw it in SolidWorks. But there's a file type, I forgot what it's called, it's like .x_t. Yeah, Parasolid, that's it. This is what the SolidWorks file type is based on, apparently. So if you have the option to convert it to this, use that. Mm-hmm. Alright, new part. So where would you guys start? Maybe on this bottom plane here
Yeah.
Yeah, that's just good.
and go up. Okay.
That's just
So we got A and B. We got to define those. And this time it's inches.
Yeah, first.
2.125 inches. And B is equal to 1.25. And you don't have to worry about the decimal places right now because the default is 2, and arbitrary is also the default, or it means they don't really care. Okay, and we'll do the material once we're done. So this time I'm going to do it on the top plane. And just draw a rectangle in here, and then I'm going to do a circle or an arc, and I'm going to relate these points together. I'm going to delete this top line because I don't need it, and I'm going to make this center point the origin. And this was B, I think. Yeah. And this was equal to A. And that's not good.
Just make that one,
Equal to B divided by 2. What's not?
You just made a tangent, though. That way,
Oh yeah, I could have done that too. Let's do that actually. And that gets extruded by, I can't tell. They always make these so hard to read too.
says wall and rib thickness 0.25 at the bottom there. What that means.
Yeah, the other one looks like it's half an inch.
I was thinking maybe this, but I think they're talking about this pocket.
Yeah, it says that there's wall and rib.
Yeah, it must be 0.25.
it's going to come out lost, bro.
You got lost?
Yeah.
Where you at?
I'll still draw a rectangle.
Okay. Harold, can you help Wesley?
Oh, sure.
Okay.
You already asked me.
Oh, I got a bad equation.
Did you set A and B?
Yeah, the A and B are the same.
Okay, so go to, you drop down. Or, and it's like a good one. There. Okay, so don't, yeah, drop it. Run.
So I'm going to draw this circle at the top next.
No, draw that.
Close quicker.
Yep, one. Can you click this one? And yeah, it draws it backwards. Did you click that one?
Yeah, I did.
Is that what this is?
That's what it is.
Do you want to get an actual mouse so you don't have to like, just click 50 million times?
Sweet. That's what it
You don't have to
What was the thickness again?
0.25.
Oh, there you go.
I'm going to do these little cutouts here.
Get a mouse.
And what I think I'll do is make another axis. And I'll use that to make a plane that is at 45 degrees of this.
Well, they make it these you not use pencils, just don't use them.
Before Harold has a heart attack.
This one doesn't work?
It works.
Okay. Use that one.
Where's the receiver?
It's in there.
Oh, so it's right here.
It's inside of it. It's hidden.
Out of curiosity, how long did it take you to get to this level of mastery?
It's just not
So, I actually did an Associates of Arts in or Associates of Science in Computer Aided Drafting and Design back in Tampa, which was like all AutoCAD, right? So there was a class in Inventor, but that's it. But it was like 2 years, probably 3 years of messing around and interest in this. In high school, I got interested in like Photoshop and Illustrator, and then I found out there was like 3D programs that was like way better, you know, third dimension. So I started playing with those, which got me into CAD, and I've always just been doing that now. Yeah, it's about 3 years probably.
Shift, click origin.
In SolidWorks.
extrude that 0.25. Nope. Oh, it's not. Yes, this right here, that, and that, one. Both of these. And the same thing. Look, it's the last one.
How much time is it for the test, like, they give you for each question? Or how much-
Okay,
Give you one question, one time?
so it's 3 hours in total. I don't know exactly how many questions there are, but I think there's like 3. I think there's like 3, just like what we did here.
And that's for the associate?
Yeah, it's for the associate. And yeah, it covers all this stuff, you know, sketching. I think they get into a little bit of assemblies or mates. Or I don't think so actually. That's the professional one. Then you got to cover all this stuff. Collision detection and assemblies. And then you get expert, and it goes on. Yeah.
When you mentioned the find the plane, again, how you did the thing?
How I did the what? The plane? For the last one that I just did?
How you did the plane? So it won't be part of any of the existing ones.
Wait, what?
How do you define the plane?
Okay. So you can define a plane just like everything else. You can go select a plane. So you know how to get to the plane part, right? The reference geometry window and then plane. And you have references. So you reference it. SolidWorks wants to know where you want a plane. So you say, you know, first reference is this thing. And I could say it's perpendicular to that, meaning it's on this plane instead of parallel with it. Or I could say coincident with it. And in this case, I want it coincident. In my second reference, I want to be the plane that runs straight through here, which is this one, the right plane. So now I want it to be 45 degrees from this one plane. So here what I'm saying is my first reference is this axis that runs through here. And I want it to be coincident with that. So it's in the same line. And you could say perpendicular, but we don't want that. And then my second reference is the right plane, which is this plane that runs straight through here. And I want it to be 45 degrees off from there. So I could say 90 or wherever. Or I could, you know, use any of these other ones. In class, I don't know if you remember, our professor was trying to make a plane between two faces. And there's a way easier way to do that.
Hey Paul, which one was the B measure? Was that the
B?
yeah?
1.25. So if I wanted a plane in the center of this place, this face, and this face, I could click this face, and I can click this face. And it automatically knows I want a midplane between those two faces. Or say I wanted a plane that's 90 degrees from this edge here, like facing downwards. I could select this face and this edge, and then I change this to 30 degrees, and it'll automatically reference it that way. So this plane is parameterized to stay there, right? We have
if you wanted to do like a tangent to
the circle here. Yeah. Yep, you can do that. Go plane, And then you need a second reference because it could be anywhere around here. So you can say I want a plane to be perpendicular to this, but 30 degrees from here. So now it's both tangent with the circle and 30 degrees with the face. And you can get more complicated and say, well, this would give me an error actually. But you could give it a third reference too. And then here I'm offsetting. So I want a plane that's offset 1 inch from this plane.
What's the diameter of that hole?
1.25, I think. No, 0.75. Sorry. So now I need to cut a little hole in here. And try to use relations as much as possible rather than dimensions.
What angle is those circles in that base supposed to be? Like your plane was at what angle with respect to the,
It's 45.
so the 45?
Yeah, or from the center. 90 apart from each other. Yeah, that's a good question. Yeah, 45. Yeah. And it's 0.19 from the top face here. Now it's fully defined. I can go extrude cut in the other direction up to next. Now I'll cut that out. And now this is one thing I love about SolidWorks. I can actually mirror this feature I just made. So instead of doing that over again, I can say I want to mirror that feature I just made about this line. Now I got another one.
That surface.
Now we need
So to make this the other hole in the center, you just mirrored it?
Yep. You can just go
What was the angle offset from, or what's the angle of that hole?
45.
45?
So you select the right plane, or in my case it's the right plane.
So you mirror the cut?
The feature, yeah.
Oh, okay.
So I'm telling SolidWorks do the same exact thing on the opposite side across.
And so there's a mirror feature?
Yeah, you can go up here and mirror,
Oh, okay.
and there's, yep. That's really useful. I use that a lot.
Colin, how do you click on a normal tube?
What?
Normal tube option?
There's no null option. Oh, there it is now. Now it's there.
Control 8.
Yeah, we're doing that. It wasn't doing anything on this keyboard. Oh, Control 8.
This is pretty cool.
No? Oh.
0.375. No, just 8.
It's just, it's slow sometimes.
It makes it more to review. That's exactly what it says it does.
So this could be an issue here. When I extrude this thing out here, I'm gonna get a zero radius error right in the center here. I think. Let me see. Yeah. Zero thickness geometry, because there's zero thickness right here. So a way around that is,
Yeah, it says that.
yep, you can just merge these 2 points together, make this horizontal.
Why can't I convert these entities?
I don't know.
This version
And then there's a fillet here
There's no
of 0.1.
Yeah, it's,
There we go.
It's not converted. Oh, why aren't these entities converted? These entities. I'm trying to get this line related to that. It's not letting me select these lines at all.
You trying to convert it?
Yeah.
Why?
Well, I was trying to convert this square because it wouldn't let me select this to make that relation. It won't give me the coincidence relation.
Are you on that base?
I'm on this coin.
Yeah, I don't think this is on that coin.
Should be.
Oh, it's because you did a section view?
Yeah.
Yeah, that's why. So select the face instead, or the outside face,
Okay.
and then select that point. Does it pass through there?
It's the same way you did it,
What are you
right?
trying to draw?
I was trying to go out sort of. I wasn't sure how you did it, so I was just doing it this way. By the time we got to that, he was still doing the circle, so.
Okay, yeah. So what I did was,
I just saw you go plane here. See if it's in that.
I offset the plane by like 1 inch. In the opposite direction. I drew on that. Cut through it.
Oh, okay.
Then from the inside.
Oh.
Every time I'm trying to make this, the whole, the two little poles, it gives me zero reference to geometry.
Okay.
I don't know why.
Now you have the sketch already?
Yeah, I have it in the, thing like
I want this reference.
swing, so then, it's just up through, right?
Yeah.
So I thought you were here for the first tutorial. You were sitting right here, weren't you? Nope. This one's song, you were sitting right here at the first tutorial.
That's because you're. How did you make this plane?
Got related to this app, with this process.
Oh, you made a tangent, okay. Well, it's actually not.
Oh, you're on VMware, aren't you? That's why.
So is it cut to this side? Well, not like that.
It was because you had a tangent, so you had like zero thickness as it came around that face. there.
Oh.
So we can't do that again.
What's the diameter of that small hole?
How did you do it before instead of the way I did it?
So what I did was I made a plane here,
What's the URL?
and then I offsetted it by an inch out that way, and then I sketched on that face. And my origin is in the center of that circle. So if you go normal to this circle, you can see it's like on the origin.
Okay.
And then I just extrude cutted up to surface, or up to next.
Okay, so to offset it, you just click on the plane and use it one.
Yeah. Now this is coming together now. I'm gonna sketch here.
I'm gonna do that shit. So you want to do that? I don't have any of these dimensions. Is there a link to that drawing that I can just look at easily so I don't have to keep waiting for you to go back to it?
Yeah, hold up.
I like it.
So it's this big thing here.
Hold on. I'm just trying to get this to respond to stuff I'm clicking on.
Yeah, these relations are your friend. You're gonna get to know the relations.
Does it tell you the thickness of the fin?
Yeah, it's 0.25, just like the rest of it.
Okay. How did you fix the rebuild error from the fin?
From the fin.
Yeah.
Oh, so what I did was I went in farther. See if I can find it. Here it is. Yeah, I let these come all the way down inside this piece
Okay.
so that it wasn't zero there. Yeah.
So I guess that just happens a lot when you have any circles and
Yeah,
everything's touching.
you have to work around them, yeah. So this is interesting. This is, you extrude cut this to 0.06 from that edge. Offset from surface 0.06. And then fillet everything in there. What?
It's a weird part.
Yeah, I know. Alright, and it's alloy steel. £0.48. Oh, pretty close.
You know why? Because you didn't finish it.
What did I miss?
That little hole in the side.
Oh, yeah. Probably would have passed anyways, though.
Yeah.
That's a nice thing, like, they don't...
0.48 answer.
Yeah, that's true. Yeah, it goes all the way through. This recording's been going for 120 minutes now. It's gonna be a giant file.
This is one pallet instead of like 6. Yeah.
Yeah,
So it's like only one pallet's gonna fill 9 times.
I'm probably gonna be sitting here waiting for it to, like, write it to disk for the next couple hours.
You're gonna start over again.
Yeah.
You get to 98% and start over again.
Did anyone see where the vertical height of this thing is? What's this dimension? Or is it just in the center of this thing?
I think it's just in the center, but. Isn't it, if it wasn't, they would use a center line.
See, there's no dimension here. Oh, that's this pocket, yeah. Yeah, I think it's just in the center. That's from this edge over. Yeah. All right.